Good morning all. We have already studied what is meant by chemical shift in NMR. Now we are going to see what is indirect spin-spin interaction as far as the NMR spectroscopy is concerned. Indirect spin interaction. So as the name implies, there is a spin-spin interaction. Since we are describing about the nucleus, there is an interaction between the spin of the protons in the nucleus corresponding to one group and the spin of the protons corresponding to another group, and the interaction is not direct. That is called indirect spin-spin interaction. So let us revise the chemical shift. We have already seen that in the case of acetaldehyde, that is CH3CHO, we are getting two peaks. That is one peak corresponding to the CHO proton and the other peak corresponding to the CH3 proton. And already I have mentioned that this is under this NMR spectrum is seen like this under low resolution. That is, the resolution of the spectrometer is low. If you use a low resolution spectrometer, then the NMR spectrum of the acetaldehyde contains two peaks, one corresponding to CHO proton and other corresponding to CH3 proton. So what is NMR means? When you have a nuclei that is put in an external magnetic field, and its energy level will split corresponding to the magnetic quantum number Mi, and in that situation, if the molecule absorb a radio frequency wave, then there is a transition between the magnetic energy levels and you will get an NMR spectrum. And the NMR spectrum of acetaldehyde shows two peaks. That means different protons absorb the radio frequency waves in different manner, and under low resolution you will get two peaks in acetaldehyde. Now let us see what happens if the resolution is increased. Let us see what happens when the resolution is increased. What happens at high resolution? Now, if the resolution is increased, we will realize that actually this CHO peak is not a single peak. It is a collection of four peaks, and due to the low resolution, we are feeling that the peak is 1, and if you resolve the peak into further, it contains four peaks. That is, your CHO peak is not 1, it is actually a quartet. So we can say that the CHO peak is not single, it is actually contains four peaks. With the intensity ratio 1:3:3:, sorry, it is not like that. Your CHO peak is not 1. It is actually a collection of 4 peaks with the intensity ratio 1:3:3:1. Like that. It is intensity ratio 1:3:3:1. Your CHO peak under high resolution. So we can say that the CHO absorption peak we can see that the CHO absorption peak initially it is a single peak. It split up into 4 peak. That means we can say that the CHO absorption peak split into quartet. Doublet means 2, triplet means 3. In the same way, quartet means 4. So this is actually we see under high resolution. When the resolution is increased, we can see that the CHO peak is not 1. It is a collection of 4 peaks with intensity 1:3:3:1. Similarly, if we increase the resolution, you can see that your CH3 peak, it is a collection of 2 peaks. CH3 peak is a collection of 2 peak. Initially it is a 1 peak under low resolution. It is actually made of 2 peaks. Okay. With the intensity ratio 1:1. So what is the reason for this? What is the reason for this kind of splitting? Let us see the reason. What is the reason for this splitting? So if we consider acetaldehyde, and if the molecule is placed in a magnetic field, and if the molecule absorbs radio frequency radiation, then under low resolution you will see there is 2 peaks, but the peaks are not 2. Each peak contains several peaks. For example, CHO peak is not a single peak. CHO peak is a collection of 4 peaks that is only observed at high resolution. Similarly, CH3 peak is not a single peak. It is a collection of 2 peaks that is visible if the resolution is increased. So what is the reason for this kind of splitting? So the reason is that the reason the magnetic field experienced by the proton in CHO group is influenced by the spin arrangement of proton, the spin arrangement of proton in the adjacent group. This is the reason for the splitting. That is, the magnetic field experienced by the proton, the whole NMR is happening because we are putting the molecule in a magnetic field. So actually what actually happens is, when the magnetic field experienced by the proton in one group is influenced by the spin arrangement of proton in the adjacent group. So there is we can say that when the magnetic field experienced by the proton in one group is influenced by the spin arrangement of proton in the other group, then we can say that there is an interaction between the nuclei of the two groups. So we can simply say that there is an interaction between nuclei of two group. And if you see that if there is an interaction, it is not a direct interaction. And another important point is that there is an interaction and between the nuclei of two groups, and it interacts in such a way that there is a spin-spin interaction, because the magnetic field experienced by the proton in one group is influenced by the spin arrangement of proton in another group, means there is an interaction between the nuclei, and the interaction is spin-spin interaction. And we know that the nuclei is covered by electron cloud, since nucleus is covered by electron clouds. We can say since the nucleus is covered by electron clouds, we can say that the interaction between the nuclei, the interaction between the nucleus is through electron cloud. So when the nucleus is interacting, means they are not directly interacting, not a direct interaction. The nuclei is interacting. The interaction of the nuclei is not direct. They are interacting through the through the electron clouds. So it is called indirect spin-spin interaction. That is why it is called indirect. So it is called indirect spin interaction. And it is specified by, or it is characterized by, spin coupling constant. Spin coupling constant J. So to summarize, under high resolution we will see that each peak in acetaldehyde composed of several peaks. So what is the reason for observing that? That is, your CHO peak is a collection of 4 peaks, CH3 peak is a collection of 2 peaks. What is the cause of that splitting if the proton absorb the radio frequency waves? What is the reason? The reason is the magnetic field. Reason is that the magnetic field experienced by the proton in one group, for example in the CHO group, is influenced by the spin arrangement of proton in CH3 group. So there is a interaction between the nuclei corresponding to different group, and that interaction is a nuclear spin interaction. But how this interaction is possible? Because the nucleus is covered by electron cloud. So when the nucleus is interacting, means the nucleus is interacting through the electron cloud. So it is not a direct interaction between the nucleus, it is interacting through the electron clouds. So it is not a direct interaction, it is an indirect interaction. So it is called indirect spin interaction. And due to the indirect spin interaction, we will see that the peaks are splitting up, and it is characterized by a spin coupling constant J. So far we have discussed about two constant, that is called, one is chemical shift is given by delta, then spin coupling constant, due to it is developed, or it is introduced to explain the indirect spin interaction. Spin coupling constant, that is J.